Good morning, everyone. Today, let's discuss classical mechanics questions. These are questions from 2024 and 23 exams. Okay, first question. How fast does a rocket ship have to go for its length to be contracted to 0.99% of its proper length? So, here a rocket is traveling with some velocity v, and due to that large velocity, an observer, a stationary observer, observes its velocity to be its length to be contracted to 0.99% of its original length. So length contraction formula is L is equal to root over 1 minus V by C whole square L0, where L0 is the proper length, L is the contracted length. And substitute the results. L equal to 0.99% L0. This is equal to 0.99 by 100 L0. Or we'll substitute this into our standard formula and we'll get 0.99 by 100 equal to L0 equal to root over 1 minus V by C square L0, and we can remove this L0 from here, and what we'll get is 0.99 by 100 square equal to 1 minus V by C square. Okay, now solve this equation. 1 minus 0.99 by 100 square equal to V by C square. This is equal to 100 square minus 0.99 square by 100 square, or this is equal to 100 plus 0.99 into 100 minus 0.99 all divided by 100 square. And this product is 100.99 multiplied with 99.01 divided by 100 square, and this is equal to V by square. And this product is, I have calculated that product, 9999.0199 divided by 100 square equal to V by C square, and this is equal to 0.99990199 V by C square, or V by C equal to, or V equal to root over 0.99990199 C. So let's check some, is there any result that comes closer to this one, or this, exactly this one. So this comes very closer to our calculated result. Let's go to next question. The generalized velocity coordinate qk dot of a classical system with Lagrangian L is said to be cyclic. That is, if a coordinate doesn't explicitly appear in the Lagrangian, then that coordinate is called cyclic coordinate. So standard result. Suppose L is a function of two coordinates x, y. So Lagrangian. Suppose Lagrangian is a function of x and y. Then their velocities must also be included. So actually Lagrangian will be equal to x, y, x dot and y dot. Suppose y dot is not present in this Lagrangian, then that Lagrangian will have only x, y and x dot. So how to find if y dot is a cyclic coordinate? You just have to differentiate Lagrangian with the y dot. If this is equal to this derivative is equal to 0, that means y dot is a cyclic coordinate because y dot is not present in the Lagrangian. And instead, so in the general case, if qk is a cyclic coordinate, then dou L by dou qk equal to 0. So here, generalized coordinate qk is a cyclic coordinate. If velocity qk dot is the cyclic coordinate, then dou L by dou qk dot will be equal to 0. So this is the relation that we needed, equation that we needed. So answer will be B. Next, Hamiltonian's canonical equation of motion are. This is a direct question. And Hamiltonian's equation of motion are qi dot equal to dou h by dou pi and pi dot equal to dou h minus dou h by dou qi. So this one is the correct one. Others are wrong. Let's go to the next question. The mass of an electron is double its rest mass. Then the velocity of electron is. So here I have to apply the relation or mass change when an object is traveling with a velocity comparable to light. So that is m equal to m0 root over 1 minus by c square. So what we have here, m equal to double its rest mass, to m0 equal to m0 root over 1 minus b by c square, or we can cut this m and write 4 equal to 1 by 1 minus v by c square, or by 4 equal to 1 minus v by c square. Again, this will give you 3 by 4 equal to v by c square, or v by c equal to root 3 by 4. This implies v equal to root 3 by 4 c by 2c. Root 3 by 2c. So below answer is fourth one D. Now go to the next one. The product of generalized coordinates and its conjugate momentum has the dimension of. So generalized coordinate q has the dimension of length, and its momentum p has the unit length dimensions of momentum. So momentum into length, it has the dimension of angular momentum. So answer will be B. Let's go to the last one. What is the mass m of a particle if the rest mass m0 moves with velocity c by root 2? So here also it's a direct question. M equal to m0 by root over 1 minus v by c square. So here we have p. We are given that v equal to c by root 2. So just apply this and we'll get the mass. m0 by root over 1 minus v square means c square by 2 divided by c square. So you can cut this c and c. What you'll get is m0 by root over 1 minus 1 by 2. This will give you m0 by root over 1 by 2. This is equal to root 2 m0. Root 2 is equal to 1.414 m0. This is your answer. So answer will be 1.414 m0. Last one. The total energy of a moving meson is exactly twice its rest mass energy. Then find its velocity. If total energy of a moving meson, the total energy according to special relativity is mc square. And rest mass, what is the rest mass energy? Rest energy equal to m0 c square. And you know the equation to find m. It is m equal to m0 over 1 minus v by c square. So just apply this equation. mc square equal to 2 m0 c square, and substitute for m0 c square by over 1 minus v by c square equal to 2 m0 c square. You can cut or cancel this m0 c square from both sides. What you will get is, you will get 1 by 2 equal to root over 1 minus v by c square, or 1 by 4 equal to minus v by c square. Again, v by c square equal to 3 by 4, or v equal to 3 by 4 c. So our solution for our answer is C for third one. So 3 by 2c. Option C for the third one. Okay. So thank you. Let's see in the next class.